In this video, we're going to take a look at two different learning targets. I can represent and interpret data with frequency tables, and I can represent and interpret data with histograms. So what do you need to know? Frequency distributions and histograms. A histogram is a visual representation of a frequency table, so the two go hand in hand. Over here to the left, this is our example of a frequency table. So they're used for data sets in which the numbers are spread out. Okay, unlike when we had our dot plot, it was for a small set of data. This is for data that's got a wider range. Used when the data values include fractions and decimals. Remember that dot plots, we only use dot plots when we had integers. And individual data values cannot be determined, unlike a dot plot. Okay, so we're just going to know the frequency of how often something happens in a certain interval. So the general rules for creating those intervals, which we call classes, you typically want to have at least 5 classes or 5 intervals, and 15 would be probably about the max you'd want to have. So classes must be the same size. They cannot overlap. They need to allow for enough bars in the histogram to get a sense of the distribution. Okay, you want to be able to see the shape. Is it symmetric? Is it skewed? If you don't have enough bars to determine that, then you probably need to go readjust the classes. So this is the frequency table. So notice here that my first class is between 0 and 4, and there are 3 items in it. So we went and we drew a bar up to 3 for this first class. My second class, 5 to 9, has 8 items in it. So here's my next bar of 8. And then the next class had 9 items from 10 to 14. Notice how my bars, they're all right next to each other. There's no overlap, and my classes are down here. They're all the same size. Okay, the classes have to be the same size for each class. Okay, so let's look at an example here. So frequency tables, distribution. So if you'll remember, we have 3 ways to describe distribution. You have your symmetric data, okay, when things look rather symmetric. You have your bell-shaped or your uniform. And then you have skewed data. So you can have something that's skewed left, where that tail is on the left side of the graph, or you can have something that is skewed right, where my small part of the data is on the right side. Okay, we can identify that same information even though we're given a frequency table. Notice here in my table that on the lower end, which would be the left side, okay, because remember this is on a number line. These are both on number lines. Okay, my data is much lower on the left side of my number line than it would be on my right. It gets much larger from where we started. Okay, so the distribution here is skewed left. There's fewer data values in the classes with the lower values. Some people find it helpful to like pick up your frequency table, and you can kind of turn it and rotate it to kind of help you give a visual of what a histogram would look like. So where is the tail? That's where the less data is going to occur, and that's where the data is skewed. So since we have less data at the front end, that would be skewed left. Okay, so let's look at some more examples. We're going to do 3 examples, same process. If you would like to pause and try and check, feel free to do so. We're going to do one at a time. So here's my first frequency table distribution, okay? And now I've reminded you that if it's towards the front, that's the left side of the graph, and it's towards the bottom, it's the right side. So if we look here, these values here are much smaller than they are here. So if I have much smaller values on the left side, okay, those smaller numbers on my number line, that data is going to be skewed left. Okay, so that would be D, just like the one we just did. Okay, now if I look at this frequency table, I've got larger values up front, and then I get smaller towards the right. So if I get smaller towards the right, that means my data is going to be skewed right. And then lastly, here is my frequency table. Same classes. I look here, I start off small, I'm getting larger, and then I get small again. So small, larger, smaller. This guy is going to be symmetric. okay? And it looks like it's going to be about a bell-shaped curve because we're doing that gradual smaller to larger to smaller, okay? So that would be A. If it was approximately uniform, you'd have a table that it would have values that are almost all the same. Okay, so what do you need to know about finding the mean and the median on a histogram? So when we have that visual representation, it's very similar to when we looked at dot plots. If we have a bell-shaped histogram or a uniform histogram, the mean and the median are going to be approximately equal to one another. If our data is skewed, if it's skewed right, okay, the mean, same thing, the mean is pulled in the direction of the tail. So since I am skewed right, my mean is being pulled right, so it is greater than. If my histogram is pulled or is skewed left, my mean is pulled to the left, which means it's going to be less than the median. So let's look at this example of using histograms. All right, so members of a garden club sold plants as a fundraiser for their club. The histogram shows the number of plants that each member of the garden club sold during the fundraiser. What percent of members sold 50 or more plants? Okay, I'm using the same idea up here to find a percent. We take the part over the total and then we multiply that by 100 to get our percent. I want to know who sold more than 50. Well, here's my cutoff for 50. So I want to know everybody above that. So I'm going to take that total of those who sold 50 or more. So I add the 16, the 6, and the 32 together. And then I divide that by the total members. So I have to add the 6, the 12, the 16, the 6, and the 32. And there are 72 total members. When I simplify this, I get 54 over 72, which is 0.75. We multiply that by 100, and that is 75%. So 75% of the members sold more than 50 plants. 50 plants or more, excuse me. Okay, so if you'd like to pause, try this one and come back and check. We're going to do one more application problem here. So the histogram shows the ages of cars sold at a car auction. What percent of the cars were between 20 and 39 years old? So here's my cutoff, 20 to 39. I'm looking at this cluster right here. So in my first class here from 20 to 29, there were 8 cars. And then in my second class from 30 to 39, there are 4 cars. So I know that part, I have that part. And then you could go ahead and I write the number in the histogram bar or in the class, so I can find my total pretty easily. So I take the number of cars from 20 to 39, that was the 8 plus 4, okay, over the total number of cars. That's all of these added together. 3 plus 2 plus 8 plus 4 plus 3 gives me 20. Then we just simplify. 8 plus 4 is 12. 12 over 20 is 0.6. Multiply that by 100 and we get our percentage of 60. So 60% of the cars were between 20 and 39 years old. If you need some more information on this topic, you can check out the Learning Target spreadsheet for additional resources, videos, and practice.